Hello everybody and welcome to the webinar for the Scorpion2 system. My name is Edwin Van Der Leden and I'm Product Manager for Edify Technologies for the Silverwing brand. In this webinar today we'll do a presentation explaining all the features of the Scorpion2 system. We'll also do a live demonstration including an inspection setup, but also look at the crawler features. We'll look at the Swift features, but also have a look at data collection and analysis and how to eventually export that data to be used in reporting. We'll close out with a Q&A session where at the end you'll have the possibility to ask questions. Now let's do a product introduction. What is the Scorpion2 system? Well, the Scorpion2 system is a remotely controlled ultrasonic crawler system which delivers you a major efficiency improvement to tank and vessel wall inspections. It does so by providing data collection at high speed, using a dry coupled wheel probe, being completely battery operated and being designed as a rugged and field deployable inspection system. So what are the system benefits, right? First of all, you can do inspections faster. This unit can run in data collection mode on up to 180 millimeters per second and capture high quality data. Also, it's quite simple to set up, right? It's a dry coupled wheel probe. Also, the UT configuration on the unit is designed to be easily be configurable, which includes also a feature for using floating gates. With this unit, we'll supply you with a peace of mind if you want by supplying a service plan, and the service plan includes extended warranty, some software options, calibration, maintenance, and so on. Let's have a look at the applications. This system is mostly used for the inspections, wall thickness inspections for shells and roofs of above ground storage tanks. But we've also seen the system being used quite largely on pressure vessels, spherical tanks, but also on marine hull inspections. A nice application as well is the inspection of large diameter pipelines where the unit can be driven along longer length of pipe. In general, we can say that the unit has to be used. The asset has to be ferrous for the magnetic wheels to stick, and the wall thickness needs to be between 3 and 100 millimeters, or 0.12 up to 4 inches for the capabilities of the UT probe. Coating preferably is less than about a millimeter of non-ferrous coating. Which is about 0.04 inches. So what does the system comprise of? Well, first of all, we'll have the Scorpion2 crawler. Second, we have the Swift UT, which is a data acquisition unit, and we'll have an umbilical, which basically connects the crawler to the data acquisition unit with 50 meters of cable or 164 feet of cable. We'll also supply a tether line which must always be used when this system is deployed in the field. Let's have a look at the Scorpion features. Well, first of all, we said that we have a dry coupled wheel probe. Nice thing about that is that for system you do not need water irrigation, so there's no carrying around of water. The probe will use a slightly bit of oil and a dry coupled probe to actually get the ultrasound into the material. It has an active probe head where the probe is automatically lifted off the surface. So whenever we do a maneuver with the unit, the probe head is not connected and it prevents wear. Also, we have a probe stabilization in this probe head, allowing for a constant probe pressure of the probe on the surface, gives you very nice stable results when you do the measurements. The head is designed to come as close to the weld as possible. In this case, it's about 25 millimeters, and it will capture the majority of the heat affected zone while doing the inspection. The unit has its own battery supply. We supply 2 batteries with this unit, and 1 battery charge will last about 4 hours. A single charge, if you want to charge the battery again, is about 2.5 hours. So it kind of gives you the option to continuously run with the unit throughout an inspection day. The unit can be driven at variable speed of up to 180 millimeters per second, both in manual as well as in automatic mode. The system is fitted with double encoders. One encoder is actually used for encoding the data, while the other encoder is used to control the steering and the veering of this unit. As mentioned, the unit is steerable. You can completely turn it around for 360 degrees by each wheel being driven independently. Let's have a closer look at the probe head. So the probe head, first of all, is designed with a quick release mechanism. So to take the probe head off, simply use the quick release and you have the unit dismounted from the system, giving it access for easy maintenance. Here you'll see the dry coupled wheel probe, which is actually a dual element probe with a 5 MHz center frequency. The material of the tire is quite unique and it has high wear resistance, but the attenuation of the material is close to water, so it's ideal for getting that ultrasonic signal from the probe into the material. Also, the material for the tire can be completely replaced. By undoing the head, you can take the wheel out and replace the tires quite easily in just a matter of minutes. What we've also done is we fitted low friction, high density polyethylene wear shoes, which can easily be removed and replaced by undoing the thumb screws. The probe head itself, the probe itself, is fitted in a gimbaled probe carriage, basically allowing to adapt for any surface variation that you might come across. Also, because the probe head is pivoted, it will allow for suspension of about 12.5 millimeters or a ½ inch, easily going over a weld or going from plate to plate and take a bit of a larger step. Let's also have a look at the Swift features, but let me first put the Scorpion out of the way. So this is the Swift data acquisition unit. The Swift data acquisition unit is designed to be a very portable and rugged data acquisition unit. It's designed as an IP65 unit, so it can be used outside. It has quite heavy bumpers on the side to protect it from impact, but also on the side, on the corners, it can be used as hooked for a harness which we can supply optionally. The unit is quite light and easy transportable, and it comes in its own transport case. As you can see, it's quite rugged, and it has rugged keypads, hard keypads on the side. The unit is battery operated. It has 2 batteries on the side, and both the batteries are hot swappable. One battery can be taken out and the unit still functions as normal, while the battery charge for the batteries is about 6 hours, and again with these batteries we have a fast charge option about 2.5 hours. In the middle you find the touchscreen, 26.4 centimeters or 10.4 inches. It's non-reflective and high resolution, so it works quite easily. And on the side here, as you might expect from a newly designed unit, we'll have the interface and connectivity options for Ethernet, Wi-Fi and USB. Internally, the unit is fitted with a 100 GB storage, basically allowing you to store many hundreds of inspections before that disk is actually full. Let's also have a look at the software features. So the software features, the software is designed to be easy to navigate and quite easy to set up. It shows all the important data on a single screen, and we have placed the toolbars and menu bars quite conveniently to go through every part of the process with a single press of a button. Also, the color schemes can be adjusted to your liking by changing another color schema set. And what we can do with the unit is actually store metadata, which will be tagged along with the inspection itself. All the data collected within the unit is CMAP compatible, so once you're done you can export the data, take it to a laptop or a normal desktop PC where you can do the reporting by using the CMAP compatible data. For the UT properties, we've designed it to be set up quite easily. right? Like you probably know from the RMS, in this unit we also have the option for floating gates, which will greatly improve the data quality of the system. And also we have two gates available, an A and a B gate. And then while you do the scanning, both the A scan and the B scan of your current recording are being shown in the same screen. So defects can be quite easily picked up while you actually do the inspection. Adjusting the software specifically for the UT settings can be done by both using the touchscreen and the keypad, but you can also use the hard buttons on the side. If you do an inspection, then the maximum length of the inspection is about 50 meters. And then once you're done recording and you're in analysis mode, you can actually post-process that data, change gate settings to actually optimize that data set even further. We'll now have a look at a demonstration of the system. Alright, then before we begin the demonstration, we're first going to connect the cable to the Scorpion crawler. So first I'm going to attach the cable relief hooks to make sure that the data signal cable are not being stretched too much. This tail piece actually makes sure that the cable stays away from the magnetic wheels and don't get run over. So we simply have the controls cable to connect and two cables for the actual UT signals. They're all marked on the Scorpion itself, so that's quite easy to do. As you can see, the red light is flashing, meaning the system is booting up at the moment. Once the system is ready, it will actually turn to green. If we look at the Swift, then you can see that this is the menu that will be shown when the system is starting up. This is the home screen, which will basically give you the option to either start a new inspection or load an existing inspection. In the bottom here you can see that we have the battery level for the Scorpion crawler as well as the battery level for the Swift UT. And also we see this green banner saying that the joystick is now fully enabled. So in this case the joystick will allow me to fully maneuver the crawler to a position that I want to. Then we have a help option where there's information being displayed about the unit. In the settings we can actually set the unit to go from metric to imperial, and we have some system options to either enable or just disable this joystick, which is embedded here on the unit. We can set the date and time for the unit. We can change the color palette for the B scan. We have some power management options to go make the unit go to sleep, and also very important is the wireless setting, where you can actually connect the unit to your local network. There, as we said, is the color schema that you can use. You can basically change those colors to any setting that you like. Going back to the home screen. With the new inspection, we actually have the option to fill out all the metadata with the inspection. So it's fully tagged. All the inspection data is tagged in that case. We won't do it for this time because that will take too much time. I'm going to load an inspection that I already have. And there you go. That's all my settings already loaded. Then if you want to continue, you basically go to save details and begin scan, and that will bring you to the data acquisition unit option within the unit. First thing you would want to do is calibrate the unit for the encoders. So there's not the UT calibration, but the encoder calibration. For that, you click the calibration option, and what it basically does, it travels a certain distance, which you can predetermine before you actually do the calibration. So if I set it at 1000 millimeters, the unit will run until it thinks it has 1000 millimeters. Then you can actually measure the real distance that it's been traveled, and therefore compensate the encoders and calibrate the encoders as such. We won't do it this time, but you can also save that file and reload that file whenever you need to. When I'm ready for my inspection, I actually will turn the unit around. like that, position it in the location where I want it to be. I'm going to lower the probe head on the surface, and as you can see, when the probe head is up, it also gives me the option to actually do maintenance, clean the probe wheel, or put some actual oil in. Now I'm going to line my scanner up. I'm going to drive it to my bottom position where I actually want to begin the scan. Now at this point I will click the start scan option, and you can immediately hear the probe coming down, and you see the UT signals appear on the A-scan portion of the screen. On top of the A-scan you will see the most used values for the system, so you can see the different options for the gauge, like the thickness, the amplitude height of the different envelopes. And what you can do then is change your UT configuration settings. With the UT configuration you have the option to set the range. It's currently set to 30 millimeters. We see 4 to 5 envelopes, reflections, back walls on a 5.3 millimeter plate, which is quite nice. If you want more backwall echo, should there be, you can make the range bigger or smaller to see less and get more spacing between the individual backwall echoes. You can also set the gain here, and setting the different options is quite simple. Just by tapping the screen, it will highlight the screen, in this case in blue. By tapping it again, it will open up the keyboard, and you can go to the numeric part of the keyboard to actually fill in that data. The other thing you can do as well is use the hard buttons. You can use a preset number. So let's say I want to add 1 dB. I can basically use the buttons to add or subtract 1 dB. By changing the top button, I can make bigger steps, so I can add like 6 dB. And the maximum in this case is 9. So you have freedom to actually how you want to set the individual settings. There's also a delay option where you can move the whole envelope to the left or to the right, which you would normally use for calibration. Then the second is the next one is the velocity. It's the material velocity plus the composite velocity of the wheel probe, and that would calibrate your UT signal for your second backwall echo. And then with filters we have some filtering options. In this case I don't want any filtering. It's like I told you, a 5 megahertz probe, so if I put it at a 10 megahertz filter it basically won't filter anything, but I can also smoothen the A-scans if I would like to. The crystal option in this case is dual, because I told you it's a dual element probe, so we're going to leave that at dual, but the system would also be able to handle a single element probe. And then we suited 2 options for the different gates. With the gates we have the option of actually choosing a peak, a flank floating, or a flank option. In this case I'm going to use the flank floating option, because that will give me, you know, the best possible data as the gate actually flows with the height of the amplitude for that back wall. And then I am able to set a start, a length and a level at the screen height at which I want that gate to appear. I can actually do the same for the the second gate, which is the B gate. In this case I want to move the start a little bit, so I'm going to change that setting to actually move it around, and you can see it nicely fits over that second backwall echo now. If I'm done, I can use the save option to actually save this configuration, and I'll be able to recall that configuration at a later point in time. And I can also of course then reload another configuration should I want to, for another material thickness for instance. I'm happy with the settings as they are, so I'm gonna go back to the scan, and at this point in time I'm actually ready for the inspection itself, right? So I'm gonna press the start option, and as mentioned before in the presentation we have basically 2 options for controlling the unit. It's a manual mode or it's a automatic mode, and in the manual mode, which I'm going to start first, you'll see a setting which is called offset. As you can see, the scanner is at the bottom position of the tank, but the first 480 millimeters, we're not capturing any data because that probe is not really down at floor level. So we're going to have to enter that distance where we're not measuring any data. The reason why you would do this would make your life easy when you actually start aligning the data if you use a program like CMap for easy reporting and configuration. So I know this is the 480 millimeters, and basically now I'm set to start my measurement. I click start measurement, and the system is now waiting for me to actually do the measurement. I have two options. That's either using the hard buttons for forward, reverse, stop, or the joystick. And in this case, I'm going to use the joystick. So if I move the joystick up, unit will run. On the screen you can see the defects appear. If I release the joystick, the system stops, and I tell it that this is the end of my scan. As you can see, the B scan is now being shown on the full width of the screen, and at any position now I can move my finger, and basically it shows me the result for that particular position for my scan. In this case I see that my B gate is not showing, it's not actually positioned quite right for that second backward echo. So what I can do now, I can basically go into configuration, and this is post analysis, right? Really important, very powerful tool. And I basically go back into start and then set my gate back a little bit so it captures that second backward echo. If I go back, it automatically reprocesses that whole data set, and that result can be immediately shown with the profile view, where you can actually quite nicely see the defects. With the hardware, with the hard buttons here, we also have a plus and a minus where we can actually zoom in. So if we zoom in, I can actually go to a particular location and have a close analysis of that defect. So you don't have to take the crawler off the tank. You can do analysis of that defect while you're actually there. And then with the minus button, you can actually zoom out, and you can do exactly the same with the B scan view as well. So now let's do another scan, but first I'll show you how to save, because we have a number of options how to save. So we click save scan, and then in the save scan option we basically have three options to save the data. First of all is the adjacent scan option. Basically naming the file in a certain sequence. This will go from 1, and then if you have 10 files, it will go from 1 to 10. I have a gridding option where I can say, okay, I have a row and a column. I'm currently on this row or this column, and it will automatically implement the row and the column in the naming of the file. It will also store the row separation, and that is quite useful if you use CMap as a reporting tool, because it will then automatically lay out the data for you when you actually import the data. We also have a tank shell inspection file saving option, which will basically allow me to tell the system at what scan I am and what course I am. And then also by using the separation, it will automatically lay out that data and automatically name the data as I move along in my inspection. I will go now for the adjacent scan. I will just simply give it a name. Now calling 19, and I'll click save and then tell it I want to do a next scan. I'm going to drive the unit back down. We're going to do exactly the same now, but then in automatic mode. So I'm going to stop the scanner at the bottom. I'm going to tell it to start a new scan. I'm not going to change my UT configuration because that has stayed the same. And in automatic mode, I again have the offset setting, which is still the 480 millimeters. We have the option to scan either forward or in reverse mode, and the scan speed we can actually set it to slow, medium or fast. In this case we're going to go for fast. We're going to do a forward scan. The offset is the same, and I'm going to do a program scan length of 1.4 meters, because I know that the system, that the plate is high enough to actually do that. So when I'm done, I'm actually just simply clicking the start button. The unit drives automatically. I don't have to do anything. And remember, it can be anywhere between 1 meter or 50 meters. And with most tanks being around 20, 21, 25 meters high, it was quite convenient to automatically do this. In the drive mode, you can see now that the banner here is red, basically showing that the control is now completely disabled. The joystick won't work because it's in automatic mode. The two encoders will make sure in an automatic mode that it stays on its path, so it travels upright, even though it might have some drift. But it will automatically compensate due to the two encoders on the system. So again, I've completed my scan. I'm going to stop my scan. There again is the result. Again, I can do my analysis, look at the individual results of the measurement itself, and also change the result as we go. Then we have the option to input some marker lines where we can actually say, okay, my minimum is 4 millimeters, and it will draw a marker line, and I can actually, we can see a little bit better when we zoom in. I can see here that the defect is crossing my marker line, which I've just set here. I could do the same for the nominal thickness. And the other option we have is to actually have a look at statistics. So we can say, okay, what's the minimum, the average, and the minimum and the maximum measurement. And it will draw lines, a red line and a black line. And again, I can change these colors if I want to, showing that minimum, where exactly that minimum and that maximum is for that particular scan that I did. Now, the final option that you have here, and probably the most important one, is the reporting option. We basically have a number of reporting options. So first of all, let's have a look at the export scan option. The export scan option allows you to export all the data into a tabular format, a CSV file, which can be used in Excel or Word, for instance, or any other program that can handle CSV files. I can add a step, so the system makes a measurement every millimeter, but I can choose to output maybe a measurement every 10 millimeters, so you'll have less data on your scan length. I can choose my delimiter if I need to, and then when I want to, I can simply add a USB key. As we can see, the USB key is recognized as drive E in the file, and all I have to do basically is save the export, then give it a name, any name that I would like to, and then save the file. Now the CSV data has been saved to file. The other option we have, I can find a particular point of interest and then choose the capture option. The capture option basically allows you to save image files to the disk, to the USB drive. So in this case, it's a file for the A scan, but I can also do that for the B scan. When I do that, I just simply have to click save, give it a name if I want to, and then save the file. In this case, it's already existing, but will overwrite. I can do the same for the B scan. I can save the file. I can just rename that file. And then you're done saving that image file for that particular location. And I can do that on any of the positions within the scan. So you can output multiple image files to create a report. Then if I go back to my if I then go back to my inspection settings, there you'll find the third option for exporting data. This export is actually designed for our proprietary CMap software, and it will allow you to export it will allow you to export all the data that is associated with this particular inspection. As you can see, if I save the scan, it will give it a CMX file reference, so we'll know that this is a CMAP compatible file. And if we save it, then all that data is now saved to disk and can be imported into CMAP. Okay, so this was a quick overview of how this system works. The next thing we would like to look at is the system packaging, and some other options we'll have before we will go to the Q&A. So for the system packaging, we have two separate cases. And Damien, maybe you can show the slide with the two pictures. But in one case we will have the Scorpion2. In its own case, it has a quick start guide, basically allowing you to remember all the specific details and how to set up a specific inspection. We have two batteries included. It comes with a dual bay charger. We have all the tools in there for which are needed for maintenance, if you want to take the probe out or remove the wear shoes. Also in there is a bottle of oil and a syringe to actually make sure that the probe is lubricated. And then in that case also is conveniently placed the reel with 50 meters of cable and a tether line. One thing that I would like to show you as well is the tether line which we deliver with the system. There's two tether hooks at the top where the tether line needs to be connected, and then there's a long 30-meter line which can be connected there. So there's no reason why the system should not be or could not be tethered. Also the Swift comes in its own case, which is quite light and portable. It contains two batteries for the system, which will be in the case as well, and the system manual. Now the final thing that I would like to talk to you about is the service plan that we offer with this system, and previously we already discussed this briefly, but the service plan is designed to provide you with reliability and availability of this system. It keeps the system in perfect working condition and basically protects your investment. So with the system we have the option to buy a 3-year service plan, and the 3-year service plan includes a 3-year extended warranty, so we'll extend the warranty of the system up to 3 years. We have all the software upgrades and firmware upgrades that will be available throughout the lifetime of the service plan. The system will receive maintenance when it comes back in for calibration. We'll inspect the system on critical points, make sure that everything is in an optimum position, and then we'll provide system calibration. We'll have a priority repair service, so should the unit be broken, we'll repair that with priority, and it comes with a 3-year license for CMAP. So all in all, a pretty valuable package for this unit to actually run with. So this was the end of the webinar, and we'll now go through the Q&A section, so fire away. Okay, we have a first question coming in, that is the Scorpion2 system intrinsically safe? No, the system is not intrinsically safe. It's been very well designed. It's an IP65 casing, and the Scorpion itself is an IP62, meaning that the system can be used in light rain. It's not intrinsically safe, so if you use it in a hazardous area, you're going to have to use a hot work permit to actually use the system. Okay. Then another question is what's the weight of the crawler and the Swift? The weight of the crawler is approximately 10.5 kilograms, and that includes the battery. And the Swift is about 6.6 kilograms, also including the battery. So it's quite lightweight and easy deployable. Okay, and another question is, how quickly can the system be deployed in the field? Well, as you can see that we only have three components. We have the UT data acquisition unit, we have the Scorpion crawler, basically connected with the reel, and that's the only three components that we'll use. So as soon as you turn the unit on, make the connections, switch it on, it will be powered on in less than a minute. The deployment of the system is literally a matter of minutes. There's no carrying of water because of the dry coupled wheel probe, and only 2 cases, so it's quite easy to actually deploy. And then a question on the reporting options. Well, I think we just went through that, right? We have 3 reporting options basically, which is a CSV file containing all the data for a particular scan. Gives you a nice table with a header. In the table you'll find the X position, the encoder positions with the accompanying values for the A scan reading and the B scan reading. Then we have the option to actually export image files. Image files could be an A-scan view or a B-scan view. And then finally we have the option to use the CMX file, and the CMX file will allow you to use all the data, including the raw data, including the UT data, in our proprietary software package called CMap. Okay, and then we have one final question. I think we have time for that one. What are the advantages of Scorpion 2 over Scorpion 1? Well, that's a very good point. So if you look at the Scorpion 1, which ran at a speed of 25 millimeters a second, this will run at 180 millimeters a second. So we can say that the whole system is 7 times faster. Right, and also another benefit is that it can take larger steps. We don't actually have a belly magnet anymore, but the wheels are now magnets, so we can take larger steps up to a half an inch or 12.5 millimeters, going from plate to plate or over a weld. The other benefit, I think, is the design of the system. We only basically have 2 components, a data acquisition unit and a crawler, which is connected with the reel. 3 components, easy to deploy, quite easy and lightweight to carry. I think what's also important, that the UT quality of this system is far better than the older system. The UT card in this unit is new design with state-of-the-art electronics. We have stabilized the probe, so the probe pressure is much better, much stable. You get a much clearer signal, and all in all, the signal to noise ratio for the unit is far better than the older Scorpion 1. And then finally, I would say that one of the biggest benefits is the battery system of the Swift UT. Basically has 2 batteries. There's a far longer lifetime. You can hot swap the batteries, take one out, charge one as you're still using the other one. And yeah, so that's I think that's a big benefit as well. So now I think we've come to the end of the webinar. If there's more questions, please don't hesitate, to send us an email. We'll be reading them through the webinar software, and we will supply you answers by email anyway. But should you have any more questions after this webinar, please don't hesitate to contact me or contact your nearest sales manager, who will be able to help you and be able to help you with setting up like a personal demo if you would like to. Thank you very much for your attention. Have a nice day.